Hey guys, this is worksheet number 1, what you need to know about motion along the x-axis. So I hope you can hear me okay. In this space right here, I'm going to put some information that we need to help us answer these questions. You may find that it's pretty crowded right here, so if you write big, you might want to turn the piece of paper over and write on the back. As a matter of fact, I think I am going to go ahead and turn the piece of paper over just so I have plenty of room. If we're going to discuss motion, there are 3 closely related concepts that we need to keep straight, and these are, feel free to pause the video, or you can actually fast forward the video if you wanted to, and then pause it when you get there and just write these down. So we're going to look at position, velocity, and acceleration. And all I'm going to do is give you a definition. Okay, so for position, if an object is traveling left or right, we usually use the notation x at t. It's x position at some time t, or y of t if the particle is moving up or down. For this particular lesson, what we're going to be looking at is motion along a straight line. That line might be horizontal, that line might be vertical. Right? This is the notation that's usually reserved for position. Okay, so x of t or y of t determines where the particle is located on the x or y axis at a given time t. Let's get a definition of velocity. The notation we usually use is v of t, or you can think of it as the derivative, the rate of change of the x position, or the rate of change of the y position. And this determines how fast the position is changing at time t, as well as the direction of movement. Right, determines how fast the position is changing at time t, as well as the direction of movement. All right, now let's look at acceleration, which is the rate of change of velocity. In notation, we would have a of t is equal to v prime of t, which is equal to the second derivative of the position, or the second derivative of position, the x double prime or the y double prime. And this determines how fast the velocity is changing at time t. The sign of acceleration indicates if the velocity is increasing or decreasing. The positive negative sign indicates if velocity is increasing or decreasing. And if you think about it, if velocity is increasing, then the slope to velocity, which is acceleration, then the slope to velocity, which is acceleration, is positive. If our velocity graph, you can think of it as our first derivative, if our first derivative graph, our velocity graph is decreasing, then we expect the slope or the acceleration to be negative. So, kind of putting context to what we've been doing, you can think of the position as the f function, the velocity is the f prime, and the acceleration as the second derivative, the second rate of change of position. Okay, so in this packet of worksheets, we're going to be discussing motion along a straight line. So right here, if you wanted to, you could put along a straight line. And we're going to restrict our view to horizontal or vertical lines. All right, let's fill in these blanks. If x of t represents the position of a particle along the x-axis at any time t, then the following statements are true. Initially means when time is 0. When time is 0. When I get started. When I start the clock. At the origin means my position is 0. Or x of t. At rest means that your velocity, or v of t, is equal to 0. So just some vocab, some definitions. If the velocity of the particle is positive, then the particle is moving to the right. If the velocity of the particle is blank, then the particle is moving to the left. Negative. Negative velocity, moving to the left. To find average velocity over a time interval, that means from a beginning time to an ending time, to find an average velocity, it's a rate of change of position with time. Divide the change in position by the change in time. So you can think of this as a secant slope there. Instantaneous velocity is a tangent slope, a derivative. It's the velocity at a single moment instant in time. All right, if the acceleration of the particle is blank, then the velocity is decreasing. Well, acceleration is the slope to velocity. So if velocity is decreasing, if that function is decreasing, then the slope or acceleration has to be negative. And in order for a particle to, I skipped one. Let's go back to 8. If the acceleration of the particle is positive, if I have a positive slope, a positive acceleration, then the velocity is increasing. I would have edited that and you would have never known, but unfortunately via the document camera, there's no editing. All right, 10. In order for a particle to change direction, the velocity must change signs. That's some background that we're going to need. All of this is going to be some background that we need as we advance through Worksheet 2 and also Worksheet 3. Okay, we're going to skip 11. I'm not going to cover it at this time. So we'll go to the next video and see how that video helps us do example 1 on Worksheet 2.